Okay, I'm now going to go into presentation mode, and you will see this presentation that I have already uploaded. Okay, and this is just a revision of what we covered last term, just to get your heads back into it, because the section we're going to move on to is based on this. Okay, so you'll remember that in grade 11, we had linear number patterns. They had a common first difference. We looked at that formula, Tn equals An plus C, where A was the first difference and C was T naught. Okay, that was fairly straightforward. We had a look at quadratic number patterns last year as well. They've got a common second difference. The first difference is a sequence on its own, and that'll be a linear sequence. They have a general term with that formula. The plus C seems to have got a bit lost there. And we knew how to work out A and C, and we found B by substitution. Okay, so that was all just the grade 11 stuff on linear and quadratic number patterns. Then this year, we picked up with an arithmetic sequence. Okay, and we said that an arithmetic sequence was just another fancy la-di-da word for linear patterns. And that each term is generated by adding the same amount to the previous term, which is kind of the definition of a linear pattern. This year, we took T1 to be A, which then gave us T2 as being A plus D, and obviously T3 would then be A plus 2D, T4, A plus 3D, T5, A plus 4D, etc., etc., etc. Okay. And the thing that we picked up there, after a little bit of going through those things, we picked up that the coefficient of D, the common difference, was always one less than the term number. So term 3, coefficient of D was 2, which was one less than position 3. Position 4, the coefficient of D was 3, etc., etc., etc. Okay. Right, so from that then, we can predict a formula for any term. So T15 is one less, so it's 14D, A plus 14D, term 148 is 147D. And then we can actually come up with a general formula for any term. And remember, we use Tn to represent any term in the sequence, as A plus one less than N, which is the position multiplied by the common differences. Right, and that was arithmetic sequences kind of covered in a nutshell as well. Okay, we then went on and we had a look at a new type of sequence, and this was a geometric sequence. Now, geometric sequence is determined or generated when we take each term and multiply it by a new or by the same value. Okay, so for example, there 3, 6, 12, 24, 48. Each term is multiplied by 2 in order to generate the second term. Okay, and this common number, that 2 in the previous example, is what we call the common ratio. And we represented it by the letter R. Okay, so if we consider the sequence with term 1 being A again, okay, term 1 is A, term 2 will be A times R, okay, by definition of geometric sequence. Term 3 would be A times R squared because of term 2 being multiplied by R again. Okay, term 4 would be AR cubed because now we've taken term 3 and multiplied it by R. All right, and term 5 is AR to the power of 4, again, by multiplying term 4 by R. Now, hopefully we were able to pick up that each exponent of R is now one less than the term position. So like in arithmetic sequences, where the coefficient of D was one less, here the exponent of R is one less than the term position. Okay, based on that then, okay, that's just to show you where it happens there. Based on that, we come to a formula that Tn is A, which is your first term, multiplied by R, which is your common ratio, to the power of 1 less than the position we're working with. So the exponent is 1 less, okay, than the term position. Term position is n. Right. I don't know if there's any questions there, guys. No questions. We're all good. You all happy with what we've done? Yes.
It's Carla, by the way.
Yes, Carla, I can see that.
So I don't understand what you mean by like one is less than the other. Like I think it's non-consecutive terms.
Have you got an example for me, Carla? Or has it got to do with the presentation that I've just done?
So it's got to do with the presentation. I think it's those yellow blocks that we're moving.
Okay. Let me just share my screen again and we can talk about that. That one there, Carla?
Yes, sir.
Okay, so are you talking about this block? Yeah, that says note that each exponent is 1 less than the term position.
Yeah.
Okay, so if I have a look at term 2, the exponent of r is 1, which is 1 less than the position of the term.
Oh, okay.
And then in term 3, the exponent of r is 2, which is 1 less than the position 3 in the sequence.
Thanks, sir.
Does that answer your question?
Yeah.
Okay, great. Any other questions, guys? Tiamo, I think I've actually posted it on the classroom, my girl. I'm just checking right now to see if I have posted it. No, it doesn't appear like I have posted it. So what I'll do, oh no, I have. If you go back down to, if you go into the classroom and you have a look at April the 13th, I've posted this PowerPoint on the classroom. Okay. Okay, cool. Thanks, guys. Any other questions, guys? Okay, so basically what will happen now is I did post an exercise, a revision exercise based on sequences and just sequences, arithmetic and geometric sequences. So if you go into the classroom and you work on that, I will stay on this channel until the end of the lesson. So if you've got any questions, you can just rejoin the meeting and you can just ask me your question. Okay. We good? Okay. Nix, I will post the answers. I will post those on Classroom either later tonight or tomorrow morning. Zipper, I can't really remember if they do or not. Yeah, but if you're battling with it, as I said, I'm available on the meeting. I'm going to stay on the meeting until the end of the lesson. Failing that, you guys have all got my cell phone number. You can WhatsApp me, or you can email, or you can ask a message on the Classroom. All three of those come as notifications to my phone, and I will answer them when I can. Okay. Yes, Nix, we are still going to be using our textbook. I just chose this as a revision exercise. So I'm not going to be typing up notes every day. I will be giving you exercises from the textbooks to do. Anybody not got their textbooks with them? Okay. Kelly, what I can do for you is you and Connor. Matt, you've got a question? Okay, so those of you who haven't got textbooks, what I'll do is I'll actually post photographs of the exercise from the textbook on the Classroom as well. Cool. I don't know, which one of you raised your hand, Matt? Oh, I see. Okay, Matthew. Okay. Okay, guys, if you've got no other questions, you're welcome to leave the meeting and get busy with the work, and then just rejoin it if you've got questions about the exercise. I will sign off the meeting just after 9:20. Yes, Van.
Yeah, I just wanted to ask. Wait, there you go. I just wanted to ask. Do we have to post it? Like, do we have to hand it in?
No, this one you don't have to hand in. You don't have to hand your work in. There will be exercises that I will ask you to hand in on occasion.
Okay, so is this the one like above the link for the Google Meet?
This is so it's the one with the pictures of the matchstick. So yeah, so where the one that says new assignment sequences revision.
Okay, cool. Thank you so much, Sue.
Okay. Hello, Connor. Put your mic on.
No, sir.
Yes, Jen.
Sorry, I'm a little bit confused in question 2. When I try to calculate it says it's an arithmetic sequence, but when I try to calculate the common difference, I get 2 different answers.
Yeah, both answers should have X in them.
Yes, and they should be
If
equal.
it's an arithmetic sequence, then they can set them equal and you can solve for X.
Okay. Okay, thanks, sir. I was very confused for a second there. I wasn't sure what was going on.
Okay, no sweat. You're using the fact that it is arithmetic to determine the value
Yeah.
of X.
Okay, I was
Okay.
I was a little bit confused because I was like, I expected them to be the same, but obviously
Oh, I
I'm
see.
not in a complete maths mindset.
No sweat. Cool.
Okay, thanks, sir.
Thanks, Jim. Cheers, man. Matt. Matthew.
Sorry, I lost my place where my mic was. So I joined the conversation a bit too late. I'm having the same problem with question 2. How you do A exactly? Because I know you say because it's an arithmetic sequence. So yeah, but
Okay, so if you find the difference between the first 2 terms,
okay,
you'll get 32
So-
minus 2x.
yeah,
And if you find the difference between the second and third term, you should get
Yeah.
2x minus 24, I think.
yeah,
Okay, so because it's arithmetic, it does mean that the two common differences have to be equal. So you can set those two expressions equal to each other and then solve for x.
Oh, okay. So that, yeah, okay.
And then once you found
Yeah,
the
that does make
value, and when you found the value of x and a, you can then substitute it to actually find the values of the first three, and that will help you to find Tn in the second question.
Okay, what do you mean by x and a? So obviously, if I look at your slideshow here where it says it shows you basically the general formula.
Yes, but what I'm
and you
saying
put
is,
Tn.
in question A,
Yeah.
you would have found a value for x. So let's say x
Yeah.
works out to be 7. Okay,
Yeah.
which it clearly
Oh, and
is
then you'd
not.
actually find the values
You'd
for.
actually found the values for term 1, term 2, and term 3.
Okay. Okay, that does make sense. That does make sense. And then
Okay,
you can put it into your general formula.
correct.
Okay. Thank you so much, sir.
Cool. Fatsimo? Fatsimo, you need to turn your mic on. Can't hear you.
Oh, okay. Hi, sir.
Hello.
Sir, I'm struggling with question 2A.
Okay. Let me just see. Somebody else has joined the meeting. Rach, is your question also got to do with question 2A?
Yes, sir, it is.
Okay, so I can answer both your questions simultaneously, eh?
Yes,
Okay.
sir.
Okay, so guys, if you find the first difference there, or the difference between consecutive terms, okay, you'll get two different expressions in x. So if you go term 2 minus term 1, you'll get 32 minus 2x. And if you go term 3 minus term 2, you'll get 2x minus 24. Happy with that? Okay, now because it's an arithmetic sequence, it means that those two expressions have to be equal.
Oh,
Wait, so what was the difference between term 1 and term 2 again?
Difference between term 1 and term 2 was 32 minus 2x.
Okay, thank you.
Okay, so if you set those two equal to each other, then you'll be able to actually find the value for x.
okay.
Oh, thanks, sir.
Thanks, sir.
Okay, cool. Carla,
Sir, please can you help me with question 2?
okay. We know that it is arithmetic,
Yeah.
okay, which means that if you subtract term 1 from term 2,
Yes.
you must get the same answer when you subtract term 2 from term 3.
Yes, sir.
Okay, but now if you do those subtractions, you end up with two different expressions in x.
Yeah.
Okay, do you get 32 minus 2x?
Yeah.
And 2x minus 24.
Yes, sir.
Okay, so those two now, because it is arithmetic, those two must actually be equal to each other.
Yes, sir.
So if you make them equal to each other, you've got an equation that you can then solve for x.
But sir, don't they just cancel out? Because it's
No, they
2x
won't.
minus.
So the one side has got negative 2x, and the other side has got positive 2x. So if you take the negative 2x over, it becomes plus 2x.
Oh, right. Basic math, thanks, sir.
Okay, you got it.
Yeah.
Okay, cool. Hello, Roman. Roman, you got a question? You need to turn your mic on. Okay, Matt, your question.
Okay, so you find the difference between T1 and T2, and then T2 and T3
Correct.
in the example, and then I get x equals 16 and x equals 12. Now, I mean, if you make one equal the other, you're getting 16 equals 12.
Are you still talking about question 2?
Yes, sir.
So your first difference, I mean, if you go T2 minus T1, you should get 32 minus 2x.
Oh, sorry, I was doing it another way. Sorry, I was looking at it totally wrong. I said x plus 5 equals 32 minus x, and so I'd get like 2x equals 32.
No, you're making your term 1 equal to the difference then.
Yeah. Okay, I see what I did wrong.
Okay,
Thank you, sir.
cool. Kelly? Okay, do all of you guys have problems with question 2? Okay. Kelly, Zipper, Roman. Roman, I know yours is question 2. Kelly, it's question 2. Zipper, you question 2 as well? Okay. So in question 2, you've been told that it is arithmetic. Okay. Which means that if you go term 2 minus term 1, it must equal term 3 minus term 2. Okay. So you can set up that equation because if you go term 2 minus term 1, you get 32 minus 2x. And if you go term 3 minus term 2, you get 2x minus 24. Okay. But now because it's arithmetic, those two must be equal to each other. So you set up the equation 2x minus 24 equals 32 minus 2x. And then based on that, you can actually solve the equation. Okay, so if you solve the equation, you end up getting 4x is equal to 56, and x works out to be 14. And once you've got x equal to 14, you can then actually find the values of each term. So term 1 will be 19 because it's 14 plus 5. Term 2 will be 23 because that's 37 minus 14. And then term 4 will be 27, so 13 plus 14. And then from there, you can actually work out the general term, the formula for Tn. Because then you'll have your first term, you can work out your common difference, and you can go backwards. Does that help you guys? Okay. Yes, Rach.
Sorry, sir. I'm battling to get my brain back into math, but I need help with question 3.
No problem, I get that. Okay, so question 3, we have a geometric sequence now. Okay, we're dealing with non-consecutive terms. Okay,
Yeah.
which means that we're now dealing, and it's actually been quite a nice, it's actually not a nasty one, because we've got term 5 is 4. Okay, term 3 is 5p plus 1. Okay,
Yeah.
now there's 2 terms between the 3rd and the 5th, but then there's also 2 terms between the 5th and the 7th.
Yeah.
Okay, which means that r squared is going to be the ratios. Okay, so you can actually say that those two are actually going to be equal as well. So if you take term 5 and divide it by term 3, okay, you get you get 4 over 5p plus 1. And if
Yes.
you take term 7 and divide it by term 5, you get 1 over 4.
Yes.
Okay. If we have those two, because there's 2 terms between 3 and 5, and 2 terms between 5 and 7, those 2 we can say are equal as well.
Then how did you know to divide it?
Because it's geometric. Arithmetic, we subtract. Geometric, we divide.
Okay, let me write that down.
Okay, so for arithmetic, we subtract to find the difference. For geometric, we divide to find the ratio.
To find the ratio. Okay.
Okay,
Alright.
so you can then make those 2 equal, and
Yes.
you can then solve for p.
Okay. All right. Thank you, sir.
Pleasure, right?
Bye.
Next, cheers. Next. Nicole, you also need in question 3. Next, you also need question 3. Fatsimo, you also need question 3. Okay, I will start question 3 again. Nicole, if that's not what you need, just hang on to the line and I'll get to your question just now. Oh, okay, cool. Okay, so in question 3, guys, we're dealing with a geometric sequence. Okay, which means between term 3 and term 5, I would have multiplied by the same number twice. Okay, so if I divide term 3 by term 5, that should give me an answer for r squared. Okay, because I'm multiplying by r twice. And it's very nice that they've also given us term 7 and term 5, which are also 2 apart. So those will also be equal to r squared. Okay, so when we're dealing, because it's geometric, we've got to divide the terms. Okay, so if we take term 5 and divide it by term 3, we end up with a fraction of 4 over 5p plus 1. And if I take term 7 and divide it by term 5, I get 1 over 4. Okay, but now because both of those are 2 terms apart, then we can actually just make them equal. Okay, so we can then make those 2 equal and then solve for p as in fractions. In this case, Patsimo, the question told you it was geometric. No problem. Yes, Nix.
I'm sorry, sir. I don't want to type this.
No, that's fine. I get that.
So I just wanted to ask, when you're doing, for example, for question 1, it's an arithmetic sequence, but do you have to use the term where it says a plus n minus 1d, or can we just use a plus an plus c? Is there a difference? What's like the big difference?
There'll be no difference when you're trying to find the formula. Yeah, there shouldn't be any difference when you're trying to find the formula. The big difference comes in when you're trying to find particular terms in the sequence. But with linear patterns and linear sequences, there really is no difference whatsoever. With arithmetic and linear, the way you treated linear is the way you can treat arithmetic sequences for now. When we start talking about series tomorrow, we need to have a look at something different there. Okay.
Okay, but then so for example, for the first one, if you use the a plus n minus 1d, the common
Yes.
difference would have been 4.
Yes.
And then would we say then n, because we're looking for the 100th term, correct?
Correct.
We then just say n is equal to 100, so then it would be 100 minus 1. And then what's a though then, sir?
A is your first term in that one. It's 19.
A is 19.
Yes, because did you get 14 as your answer for X?
This is in question 1, sir.
Oh, question 1. Sorry. I'm talking question 2. Sorry, my bad.
Oh, so okay, sir.
Question 1 is 5.
Yeah, because that's so that would be, so A is just always the first term.
A is always the first term in that sequence, yes, in that
Okay.
formula.
Okay, thank you so much, sir.
Okay.
Sir, does
Yes,
P
Fatima.
equal 7/5?
I haven't worked it out yet. Let me do it very quickly. I get P equal to 3.
Okay. That's
Okay, so let me just check your fractions if you've got them right. Did you get one fraction as a quarter?
Yes, sir.
And the other fraction is 4 over 5p plus 1.
Yes, sir.
Okay, so then you make those two equal,
Done.
and then you cross multiply.
Oh, yep. And then
So
I
you-
get 8 over 5p plus 1 equals 1. Oh,
Fatima,
no.
what's 4 times 4?
It's 16. Okay, thanks, sir.
No problem.
Sorry, sir.
Yes, Nicole.
I'm just going through this thing because I've done some of it, but I feel like what I'm doing is wrong.
Okay.
So for question 2, it tells us that it's an arithmetic sequence. So if we use the formula like the a plus n minus 1d, if we use that formula, do we just substitute, like, for example, x plus 5 into where, because we don't know what the common difference or anything is.
Okay, Nicole, sorry, I've got a grade 11 lesson carrying on as well, so that lesson's actually started.
It's okay, sir.
Okay, I will connect with you a little bit just now. Okay.
Okay, that's perfect, sir. That's fine.
Okay.
Thank you, sir.
Okay. Right, grade 11s. My apologies for being late. I've just finished my grade 12 lesson. How are you guys going? Okay. Right. I'm glad to see that you guys have now switched off your visuals, your video. I think you're still seeing my ugly mug though, so I'll just switch mine off. Okay. Okay. Kobus, I'm a little bit skeptical. Tana, you might have your shirt off or something. Okay. Guys, it seems like we're missing the brown rigs, eh? Otherwise, we all seem to be there. Oh, they're not joining us. Oh, wow. Okay. Okay. Interesting. Grace has just arrived. Okay. Guys, I did try and meet with you. I think I had a chat to 2 of you yesterday, which was great. And it's really great to see you guys, or well, virtually see you guys. And it's good to know that we're all on track. Before we actually get started, do any of you have any questions regarding the process? Okay, by your silence, I'm assuming that you're all happy with how things are going to run and you're all okay with using the Google Meet, etc., 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 huh? Okay, cool. Right, guys, just instead of, if you got something very brief to say, instead of actually just putting your mic on and off, there is that chat function. So you can just type in something in the chat function and go through that. Okay. I don't know if any of you have actually downloaded the whole Nod add-on. Wandila, I see you've used it and you've given me a thumbs up, so that's cool. That's another way of doing that. Okay. Guys, we are going to need to move on with the syllabus just to be able to make sure that we're keeping track with things. Bo, that's not quite the case. Oh, sorry, yes. If you've got Google Chrome, then yes, it works. But you can also download Chrome onto an Apple, so you don't have to use Safari. But you know what? You don't really have to do that. I understand data is like gold nowadays. Yeah, so just keep working on the chat. The chat will work as well. So yeah, have you guys got any questions regarding the process, regarding how the term's going to unfold and things like that? Okay, cool. Thanks, Luke. Yeah, Michaela, important question. And it's still something that is, or that I'm certainly trying to plow my mind through. It's a challenge from that aspect because, you know, I can trust a lot of the others in the class, but I know people like you and Abby are probably going to be cheating and using photomath or something to answer the questions. Just joking. Okay. But for the time being, we're not going to be doing any tests online. We are hoping to be able to start school again on the 7th of May. So up until then, we'll probably be making a use of a lot of sort of informal stuff, where you'll need to submit perhaps a classwork exercise, or I'll throw up a quiz on Classroom, or something like that. And it'll all be counted as informal assessments. So in terms of formal assessments, we are certainly applying our minds to what we're going to do if we need to do anything. Because hopefully we'll be able to get started again on the 7th of May and be able to move into schooling as normal as schooling can be. Yeah, it is one of those things that does present a challenge. So whilst I can probably trust all of you guys, and would like to be able to say that we can trust everybody, we know the stress and reality of assessments and marks and things like that are going to put pressure on people to maybe try and use something that is not supposedly there for us to be able to use. Abby, your question, and again, I know that this actually uses data, and data is something, as I said earlier, that's like gold. So what will happen is you'll have some brief lessons here, probably 10, 15 minutes of me talking or going through a presentation, and then you'll have an exercise to do. I will stay on the line for the duration of the actual lesson. I will stay on the meet. So once you've started the work, you can actually then sign off and sit and do the work and just rejoin again and ask me a question. I've just done it with my grade 12s. It's worked very well with them. Yeah. And we will continue to be using textbooks as well. As soon as we have finished kind of the introduction of where we're going, then we will go back to using the textbooks. Does anybody not have their textbook with them? In other words, do I need to take photos of exercises and upload them?